Hello, we're back for part 3 of 5 on artificial intelligence, this time talking about machine learning. The idea of machine learning is that we're going to have a machine, a computer, learn something. And that is, I don't simply give it the rules, it has to figure out the rules on its own. It's going to learn something. There are a bunch of types of machine learning, but we're going to talk about classification because it's the most widespread by far example. A classifier is an artificial intelligence program that's going to be given a bunch of examples of something. I'll show you what that means in a minute. And we're going to tell it a bunch of things about each example called the features. And we're going to use the input of here are my examples, here's the value of each feature for the example, to train a model that helps us explain what is it that separates these different examples from each other. And we're going to always have a bunch of different classes that we could put our examples in. And then we're going to give it new examples that it's never seen before after it's trained the model. And it's going to use the model to decide this should belong to this class or this should belong to that class. There are many different kinds of classifiers that write many different kinds of models on the inside. We're not going to worry ourselves about the details of that. But here's an example. One of the very early, very important applications of machine learning was being able to look at text that is written or printed and figure out what letters are there. In the bad old days, when you took an envelope out, you wrote an address on it, you put it in the mail, somebody at your local post office had to read it to know where to direct it to. And then it arrived at the next location, and somebody had to read it to know where to direct it to, and so forth. It might go through a bunch of stops, each time being read by people. Nowadays, all that reading is done electronically, and people only get involved when machines can't figure it out. And that's been true actually for quite a long time. So how would you design a computer program to be able to tell, is this letter an A, a B, a C, a D, or whatever? Well, it can look at a drawing of an A like this. In this picture, the places where there are red ones, there's some ink on the paper, and the places where there's black zeros, there's not any ink. Not every A that somebody draws is going to look like this, but some are. So I can get a whole bunch of pictures of A's like this, and also a whole bunch of pictures of B's like this. And then I can give my classifier, here's all the pictures of A's, and tell it these are A's. Give it all the pictures of B's and tell it these are the B's, and have it learn this model that lets it look at brand new pictures and decide whether it's an A or B. It's probably not going to have perfect accuracy, but it can do something like tell me, I am 81% certain that this is an A. In order for it to work, though, I need to give it features. So features are pieces of information about each of these drawings that might or might not be useful in distinguishing A's from B's. For example, one figure might be, does this thing have vertical symmetry or not? This does not have vertical symmetry at all. If we fold over the top over the bottom, they look nothing like each other. On the other hand, if I take a capital B, that does have vertical symmetry. If I take the top and fold it over the bottom, they look identical. What about horizontal symmetry? My A does have horizontal symmetry, but a B would not. So whether or not our shape contains horizontal and vertical symmetry might be good features to use here. We might also include things just like, is there anything in the upper left corner or not? Or how many total places are filled in versus left empty? Or how many things in the third row are filled in? There are many different things I might measure about these pictures and say, that's something that might matter. I'm going to tell my classifier about it. The job of the classifier will be to figure out which ones actually do matter and build that into its model. And that model could look like a whole bunch of different things. It could look like a line separating things that are on this side of the line are A's and things on this side of the line are B's. It could look like a bunch of probabilistic things connected together, saying if this is true and this is also true, then there's an 80% chance that this is true. Whatever. The details of the models don't matter to us. But we build a model, then we use it to decide in the future, is this thing an A or is this thing a B? One of the great examples of how this is used in your everyday life without you knowing it is that your email client automatically decides whether every email you receive is a spam email or a good email. Spam being email that was automatically sent isn't actually useful to you in any way. Someone has taken a bunch of good emails and a bunch of spam emails, decided on features for them, like perhaps how long they are, how many times they use the word free, et cetera, and trained a model. And now every time an email arrives in your inbox, that model decides either, I think this is a good email and I'm going to send it to your inbox, or I think this is a bad email and I'm going to send it to your spam folder. That's just one of very many ways in which machine learning is used behind the scenes in things that affect your life every single day. For example, if you are applying for insurance coverage, the company is going to ask for a whole bunch of information about you, and that's features that they're going to apply to a model. That model was determined by taking in, here's a bunch of information about a bunch of our previous customers, some of which cost us a lot of money because they had a lot of accidents, and some of which cost us nothing. And it's going to decide what category you're in and charge you an appropriate amount based on that, so that they think they can make money on you. If you are going to have few accidents, they're going to offer you a very low price, hoping to beat out their competitors. If they think you're going to have lots of accidents, they're going to charge you a very high price because they know anything less than that, they're going to lose money having you as a customer. Similarly, you go to Netflix and it suggests some movies for you. That's because someone has built a classifier that is decided based on people like you, what movies are you going to like. Self-driving cars are becoming a big thing. A lot of what needs to be decided there is sensing, and a lot of sensing is observing the surroundings and saying, is what I see there a pedestrian or a tree or another car or just a shadow? It's really important that we be able to know which of those things is which so that we know how to appropriately maneuver around them and not crash into them. So machine learning has been really, really big, absolutely hugely influential in our lives, even if you don't see it, for 30 years at this point. But about 10 years ago, there was a big revolution. Somebody came up with an idea called deep learning, or actually lots of people working together and separately. Deep learning says, I'm going to do a classifier, but there's going to be a couple changes. The biggest one is I'm no longer going to need to have a human tell me what the features are. Just show me the pictures, I'll figure it out on my own. Another is the way the model works is very, 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 very large. Takes up a huge amount of space in a computer to store, and it is very, very difficult, requires us to train for a very long time on lots of data to get it. And unfortunately, the result of this model is not really something that any human could look at and comprehend and tell you why it's making the decisions it's making. With traditional machine learning algorithms, somebody probably could do that if they were an expert in the way that classifier worked. But in deep learning, probably not. So traditional machine learning, a human's got to figure out the features. We build a model, and then that model can tell us whether something's a car or not a car. In new deep learning, I don't have to have a human extracting features. I just give it the pictures. It figures out the model, and then it tells me for new cars, for new images, whether they are cars or not. And unlike up here, where somebody could probably understand this, down here, nobody really can. Deep learning, although it is tremendously resource intensive, caused us to be getting much better performance than any traditional machine learning technique. So it has become hugely popular over the last 10 years, and all the places in which machine learning was used, deep learning can do it better than the old ways, simpler with less human intervention, and probably getting better results anyway. And deep learning has led to the next thing we're going to talk about in the fourth part of our series, generative AI. See you then.